for CS540 titled AI Enhanced Requirements Engineering and Analysis. I'm currently working on my graduate degree in systems engineering. I have a background in computer science, but no formal class in requirements engineering, so I thought this project would be helpful. So in this project, we're exploring AI enhancements for requirements validation, automated traceability, and predictive requirements conflicts. Part of the project is to identify requirements that are unclear or lacking, connect each requirement to the most pertinent design or test text, and highlight requirement pairings that conflict. Requirement data sets. Some are available in Kaggle. Some of them are hard to find particular properties that I need. Open source projects typically don't have SRSs available, and companies usually don't release them. So for extra data beyond the available data sets, I used some that were provided by NASA, and I used professional systems engineers to help me label some of the requirements in order to come up with the inter-annotator agreement scores. Classifier built using a spaCy pipeline with heuristics, which are rule-based detection. For instance, we can use modal verbs, which are kind of verbs like can, may, should, rather than more rigorous verbs such as shall. That can be used to find whether a requirement is good or not. Calculate the precision recall and F1 score. My current results are precision 0.81, recall 0.75, and F1 score 0.78. Also added 5-fold cross-validation in-gram perplexity check for underspecified nouns and set locking thresholds when the blind set F1 reaches a predefined threshold. This gives a better estimate of how well the heuristics perform across different subsets of data. Perplexity is used to help supplement the heuristics for ambiguity by detecting vague underspecified nouns and ensures that it generalizes well to unseen data, continuing to work to refine the final report. Traceability implemented sentence BERT indexing with k nearest neighbor retrieval, uses vector embedding to help determine semantic meaning. Also applied two methods, TF-IDF ranking and BM25 re-ranking, along with hyperparameter tuning to help improve performance. My current top one accuracy is 64%. Also performing an ablation study to determine the impact of performance when altering the model or pipeline. Also continuing to work to refine the final project report. Conflicts, worked on fine-tuning a natural language inference model, the Roberta large MNLI on a conflict pair subset, constructed a contradiction graph to where nodes are requirements and edges are contradictions in order to better visualize the contradictions. So a target F1 score for tuning the model, working to achieve a F1 score greater than 0.80. This module provided experience in fine-tuning a model, creating graphs to visualize contradictions, and setting a goal for the model's performance. Final report I'm working on, taking the test set, actually using non-parametric significance tests and confidence intervals. In summary, these tools provide a great foundation for plug-in development for systems engineering tools, and they can help, solve complex systems. Thank you for your attention. I appreciate it. Thank you.